Hello and welcome. Today is Monday, April 13th, and we're kind of getting to the end of AP Physics C. You see, some of you are here with us. A couple of new students have woken up, it seems. We got Matter 103, Matthew Shibata. Welcome. AP, so, hey, can you unban me, please? I can't watch because my free VPN too slow. Well, I mean, are you going to behave? That's the real question. All right. Slash unban. Don't trust the chemistry student. Yeah, I know, right? He's reformed, though. He's reformed. All right. Anyway, yeah, we're nearing the end. Today is actually, the last day of lecture, at least for new content. From here, it's just a review, putting things together, getting ready for the test, etc. Um, so over the spring break, you should have done all of your homework, your Crack AP homework. All that is due today, 11:59 on Canvas. Make sure you take pictures of, similar to your summaries that you've turned in. You have to save it as a PDF file and then submit it. Okay. Make sure you do all of your test corrections or just justify all the MCs and stuff. Don't BS it. Don't show, like, if you got 100% on everything, then start justifying them or give me some sort of reasoning how you got your answer. All right. So anyway, that's due today or tonight, 11:59 p.m. Don't wait until 11:59. Hopefully, I really hope you didn't put it off until today. Sword Hero, 7.9k points. Yeah, this guy wakes up in the morning and lurks during honors physics so he can rack up points. 1 page per test. I thought we had to explain everything. Yeah, that's good. That just makes it easier for me to grade. I'll just give you 100% without looking, right? So, good job, AP1 student. Um, Now, the harder you make it on me, the more time I'm going to spend on your work, the less likely you're going to get 100%. Sure, you did. Uh huh, uh huh. Well, when you say explain, like, technically you didn't have to you didn't have to write a sentence and justify everything. So if you just showed like work via like some sort of formula or something, then for some of them a formula is enough. But if you justified it, that's good. You're preparing yourself for the AP test. All right. Why are you guys mad at doing more work? I don't understand. When you get work in the job field, right? There is no minimum that you have to do. Okay, your bosses want the maximum that you can do. So you're always trying to impress not just your boss, but also potential clients and everyone else. So you want to do the maximum that you're capable of, not the minimum that is required. Okay, so anyway, let's go and talk about the new information we got from College Board regarding our AP test, and then we'll start our last day of lecture, and then we'll be done with everything. So the College Board, as you know, has released a bunch of stuff for our test. So starting with the mechanics test, well, of course, they're both on the same day, of course. So let's see, AP test, APC test. Okay, so it is May 11th. May the 11th be with us all. We are day one, so we're going to start everything off. It's May 11th at 9 a.m. Pacific, so you guys got to wake up early. 9 a.m. Pacific. All right. And then the magnetism test starts a little later. at this is mechanics mech E&M at 11 a.m. Pacific. Okay, so you're going to take tests back to back tests. Oh, okay, man, we'll move it then. That's a good one. Wireless high five for that one. Good job, Sword Hero. Where's our wireless high five emoji? Do the Renegade a caption how an electron moves in a uniform magnetic field? Online debate tournament at 9 a.m. Dang, that sucks. Wireless smack in the face. Oh, for Ved? Yeah, wireless smack in the face for Ved. Uh, Alright, so anyway, our mechanics test is at 9 a.m. The E&M test is followed at 11 a.m. So as you know, the whole thing is online. So online test. College Board will send you login information. Okay, it's the same MyAP email that you used to register. So make sure you check that. All right. So we'll go one test at a time. So listen first, and then I'll take your questions. So it's an online test. It is expected that it is open notes. However, no looking online. So don't be trying to Google and talk on Reddit. Don't chat with others. So no external sources whatsoever. So if you're a good AP1 student like Liam, and you did like a 3-reading binder for AP Physics C, even though you didn't have to, then you can just look at your 3-reading binder. It has everything organized properly from notes and activities. You can just scroll through them and get a 5 easy. Well, assuming Liam, followed all the things he learned from AP1. So Open Notes, you can only have their program. So they haven't released this information yet, but they will give you a program that you will use to log into their test taking thing. You should only have that thing open, nothing else. Okay, you can only have one device logged into that, and they have stated that there will be technologies implemented to spy on you, so that you're not cheating. And they didn't tell us what it is. It was pretty big brother of them when they were talking about it in the web conference. But anyway, it's not webcam. It's basically they're going to track what you're doing online. So when you have that program open, don't do anything stupid. Don't cheat. I mean, you shouldn't have to cheat to pass this test. It's pretty easy. So anyway, and they've made it clear that they will go to any extreme deemed necessary. So if you do, this is the College Board. They will send this stuff to all the colleges that you want to go to or got accepted by, and they could rescind the acceptance that you got. So yeah. So anyway, it's an online test. You log in through their credential. It'll be a program that they will provide. Once they release all this information, I will walk you through using it, and then before we actually take a test, we'll do a mock exam, so it's not the first time using this program, so you know what to do, etc., and how to use it. So no help. Each test is approximately 45 to 50 minutes long. So let's talk about the tests themselves. All right, so and both kind of follow the same format. Okay, so you have it'll be locked just like your Canvas quizzes that you've taken thus far. So you can't go back and forth between questions. So you get 25. So both tests. Question number 1. For both tests. Question number 1, you get 25 minutes for the question. So as soon as it starts, you get 25 minutes for the question. Okay, so you can read it, or start writing on your notebook paper. You could do it that way, or start typing or whatnot. You get 25 minutes for the question itself, and then after this 25 minutes is up, the question is locked, and then you get 5 minutes to upload. So if you did this by hand and you wrote it on a piece of paper, you are allowed to take a picture with your phone, send the picture to yourself, and then upload the picture as an attachment within these 5 minutes. Okay. Otherwise, if you didn't do it by hand, you would have to have typed it all up and then copy paste it into the answer box. And it is possible, even doing like FPDs and stuff, you can just type up the FPDs, and that way you can submit it via online directly. Okay. Well, Bernie Sanders quit, so he dropped out. No point in talking about Bernie Sanders right now. All right. So question number 1 is 25 minutes, and then you get 5 minutes to upload. This is worth 60% of your test. Okay. And then we have question 2, which is 15 minutes only, which is a smaller question. And then you get 5 minutes to upload. All right. Remember, these are locked. So once question 1 ends and you uploaded in the next 5 minutes after the 25, then the question 1 is locked. There's no going back to it. Okay. Then question 2 pops up, and then you get 15 minutes to answer question 2, and then 5 extra minutes to upload your answer. Of course not, AP1 student. No. The questions are designed to be not calculations, so they're all free response. That is, obviously they're free FRQ questions, but they're open-ended FRQ questions. So design questions, paragraph questions, justification questions. Well, that's the hard part, right? Obviously, if it was just calculations, then the calculations would be simple and everyone would have the same answer. Zachary could do what? Here's 50. Zach is here? No, he's not. Wait, is he? Torben? No, he's not. Oh, during the sorry, I missed it. No. They're gonna track your. I don't know what they're gonna do, but just don't do anything stupid. This is your life. You get caught here, and that's the end. I'm sure the NSA is gonna spy on you, your phone calls, your internet. They're gonna put a filter on your inbound and outbound, so they'll track every single packet of information that leaves and comes into your router. I don't know what kind of stuff they can do, but I'm sure they'll do it. Zo Boom finally waking up, asking a question for the spring break over. Do we need test correction? If you rewind back, go to the video section up top. If you go to the video section up top, you can rewatch it from the start. All right, 25 minutes for the first, and then 40% for the second with 15 minutes upload, blah, blah, blah. All right, let's take a look at what they're saying. Obviously, we already talked about the units, right? Mechanics was everything except for the last unit, so unit 1 through 4. These are our units, not the College Board. So units 1 through 4. Remember, unit 5 was the last one, and that was shim and gravitation, and shim and gravitation are not on the mechanics test this year. So for the E&M, it's 6 and 7 only. So this is electrostatics and circuits. This is circuits without inductors. Inductors was part of Unit 8, magnetism. So basically AP1, it's basically AP1, a little bit of capacitors perhaps, but that's about it. This is the easiest test ever. But your final, now depending on when we come back, your final is everything. No, final is everything. Now, if we come back in May, then our final is from the 7th through the 10th. If we come back in May, our final is 7th through the 10th, the week before the AP test. If we don't come back, or if we come back later, then your final will be on finals day. You think we are coming back? Very low chance in June or something. I mean, currently we're slated to come back in May, but nothing has been said. It feels like May might get pushed. That's my gut feeling. But maybe we can do your graduation. I don't know. They didn't. No one said anything yet. The governor is suggesting not to come back, but no one actually said anything. So currently it's currently it's just what happened? Oh no! Oh, there it is. Currently it's just it's May. If we do come back, your final 7th through 10th. If we don't, then it'll be finals day, and we'll adjust if new information is out. Now, I am told that the College Board will release your stuff by May 26th. So I'll know what you did by May 26th. I'll get what you did, and I'll see if you got it right or not. If I have to grade it myself, then I'm going to grade it harder. And potentially we can insert this AP test into our grades because I'm going to get the results May 26th. Yeah, I get individual results May 26th. All right, so that's the AP test for now. Well, anything else? Well, let's see. Students, okay, the first question, this question assesses students' ability to do the following: analyze representations of physical situations, determine scientific questions and methods, analyze quantitative data represented in graphs, develop an explanation or a scientific argument. Basically, they'll give you some data, some graphs. You have to analyze it, talk about it, what it means. For mechanics, make sure you understand derivatives and integrals, the relationship between displacement, and we'll start reviewing all the old stuff eventually after our test. Our magnetism test is on Wednesday, by the way. Tomorrow we're reviewing and then test. So get ready for Wednesday. Question number 2. This question assesses students' ability to design and evaluate a lab experiment. Use graphical analysis of data to find physical quantities and identify physical sources of experimental variation. Whoa. So all the labs activities that you did, good thing you have them. So take a look at those. Designing labs, what kind of materials to use. We have so much experience in combination to AP1 with APC that question 2 should be easy. For E&M, it's similar things. Question 1 in E&M, long free response question with increased emphasis on analyzing and explaining the physics C, electricity and magnetism concepts represented by representations and data. question will have less emphasis on pure calculations due to exam administration security protocols. See question 3 on the 2017 AP1 exam as an example. Ooh. So it says for E&M, see 2017 AP1 FRQ. All right. Let's keep going. For the second question, similar in structure to experimental design physics C question. Okay. For the second question, C 2012 APC. This is the practice exam that you can do. You can just actually Google it because it's released. If you just Google 2012 AP Physics C exam, you'll get the whole thing, including the multiple choice. Yeah, there's a truck. APC question 2. FRQ 3, FRQ 2. Okay, so for the first E&M question, C 2017 AP1 FRQ 3, and then for the second question, C APC question 2 in the 2012 exam. All right. Dang it, we're running out of time. This took longer than I expected. We'll talk about Hall effect tomorrow, I guess. So we'll do smaller. We'll leave Hall effect for tomorrow. I guess today is not the last day. Physics just doesn't end. When's the AP1 test? When's the AP1 test? Why does that matter? Oh, because you're taking it again? It is Thursday, Thursday at 1 o'clock. AP1 is Thursday, 1 o'clock. Uh, 14, so 14, mixer, 4:14, 1 p.m. No, what the heck? Liam, the test starts second week of May. Yeah, it's Thursday, because APC is Monday. So Monday is APC, and then Thursday is AP1. His brain is being hostile. All right, LRC. Let's go and take out our notes. LRC. Yeah, AP Chem is also Thursday. It's the morning test, and then AP1 is afternoon. Because they're younger than you. You guys are older. Alright, time to start. You guys are distracting me. Where's my stuff? There we go. Let's go and draw a circuit. We'll have our inductor, capacitor, and instead of a battery, we will have a sine wave. Uh-oh, what is this sine wave? Justin Sung, if you're in here, this is your chance. Yes, it's AC. So this has a VO cosine omega t. VO cosine omega t. And so this is kind of like the frequency of your voltage. Inductor L, capacitor C. There we go. And if we analyze this real quick, let's do a loop rule. So we start off with VO cosine omega t minus, okay, what do we drop at the inductor? Anyone remember? What's the voltage drop at the inductor? Chat, what is the voltage drop on the inductor as you go around? L di dt, yes, L di dt. And then minus the capacitor. All right, what's the capacitor? Come on. This is basic stuff that we did at the end of Thursday. Yeah, it's just charge over capacitance. Q over C. And now that we're done with our circle or our loop, it should equal 0. So that's our loop rule there. We're going to go ahead and write this out as a function. And so instead of I, remember I is current, the derivative of current over time per time. Current itself is the derivative of charge. So we can rewrite this as L Q dot Q double dot, the second derivative of charge. Okay, I'm gonna move this to the other side. I'm gonna move all of these to the other side. L Q dot plus 1 over C Q, and now our differential equation, our second order differential equation, does not equal 0. It equals some other thing, which is makes it harder to solve. Non-homogeneous. Yes, very good. But we can kind of do some shortcuts since we don't know how to do differential calculus yet. We can do some shortcuts. And the shortcuts is to use the stuff we derived last time. Recall. Q as a function of time. Someone tell us what Q as a function of time is from last time we derived this. What is the charge on our capacitor as a function of time? Actually, we're running. In the interest of time, we're going to keep going. Well, first we start with maximum Q, Q naught. Or whatever the initial Q is. And it's times cosine of omega t. Nice and easy. All right. So if I know what Q is as a function of time, then I can easily solve for the other two. Q dot, your first derivative, negative Q naught omega sine omega t. Okay. And then my Q double dot, second derivative, is the derivative of the derivative, and that's negative Q naught omega squared cosine omega t. Okay, so let's go ahead and combine all of this with all of this. And put it all together. What do we get? We get negative L, Q double dot is Q naught omega squared cosine omega t plus 1 over C times Q, and Q is just Q naught, times cosine omega t. And it must equal VO times cosine omega t. Right? Now at max value, the cosine could only be 1. it goes to 1. So at max value, it goes to 1. Therefore, we can cross all them out because it's 1. And we get negative L Q naught omega squared plus Q naught 1 over C Q naught. Let's write it as Q naught over C. Q naught over C is equal to VO, the maximum V. Because if I set it equal to V naught, then it must be at, well, it happens only when cosine is 1. Okay, and by factoring stuff out, let's see if we can do this. Q naught is equal to VO. Yeah, this is max. VO divided by 1 over C minus L omega squared. Okay, I can multiply top and bottom strategically. Multiply top and bottom by 1 over L. Okay. By doing this, we can get Q naught. So Q naught has the maximum charge. Is equal to V naught over the inductance L divided by 1 over LC minus omega squared. Okay. Why did I do this? Well, I want you to recall what this is. What is this? 1 over LC. No. No, not torque, not tau. Interesting. It is the natural frequency of the system. We got to talk about shim. Or the resonance frequency. The natural frequency or resonance frequency is omega naught. Omega naught. And omega naught is equal to the square root of 1 over LC. And so if that's that, then Q naught is equal to V naught over L divided by the resonance frequency squared minus the voltage frequency squared. Whoa. That's the difference in the two frequencies. And what else do you notice? Okay. So if you apply a voltage, at the same frequency as the resonance frequency, what happens to your circuit? If your voltage frequency is equal to your natural frequency, it explodes. Whoa. Voila. Yes, very good. That was cool. Can you show us? No. No, I can't. All right, now to put it all together, my friends. We're nearing our end. That's how you overclock CPU. Just keep it under 1.35 volts. All right, draw your next circuit. This time we're going to incorporate our resistor. So putting it all together, the final front. Actually, I think we can. No, we'll keep Hall effect later. View. Now, why do I want AC instead of DC? Well, it's because DC is boring, whereas AC is fun. It will continuously change my system so the inductor doesn't reach steady state or whatever. If you want to learn more about these circuits, consider majoring in electrical engineering. As long as Tesla approves it, I am okay. Forget Edison. It's LRC. This is an LRC circuit. Okay, so let's go and do our loop rule. Now, obviously, this is AC, so even though I drew it going clockwise here, it's going to oscillate back and forth between clockwise and counterclockwise, right? But our loop rule, this is our pathway for our loop rule at least, not the actual current that is oscillating. He's very buff, Liam. So start with VO cosine omega t. Okay, minus L di dt. Minus, what's the voltage drop at a resistor? Here's an AP1 question. No, more like honors question. What's the voltage drop at the resistor? Well, we can use Ohm's law. And that's R times I. And our capacitor. Okay, now we have three terms. It's kind of gross, but whatever. We have L Q double dot. Oh yeah, I is a function of time. Minus R times Q single dot minus one over C. I have plus Q no dot is equal to VO cosine omega t. Okay, this is far more complex, so I'm just going to give you the solution sets. There's a couple of things we need to first discuss, and a couple of new variables. First, capital X. Capital X, it should be plus. Plus. It should be plus. Plus, what did I do? Oh, over here. Oh, what? Plus, plus, plus. Yeah. There we go. All right. Now it makes sense. X, capital X, is called the reactance. Reactance. And it is another resistance types measurement. The reactance is just the inductor and capacitor part. Basically, how much resistance does an inductor and a capacitor provide in a system? X is equal to omega times L minus 1 over omega times C. Okay. So of course, if you change your frequency very quickly, if your omega increases, remember omega is the frequency of your voltage. So if you change your frequency really quickly, then you're going to get more reactance, which is another way of saying there's more resistance in the system. Now, if your capacitor is bigger, then it's subtracting less, right? It's subtracting less. If your capacitor is smaller, it's just subtracting more. So having a smaller capacitor means you'll have less resistance. All right. So the inductor and capacitor give you reactance, and then we combine reactance to get the overall resistance of the system. Instead of calling it rec, remember rec was the overall resistance of a system that only has resistors. The overall resistance of a system that has inductors, capacitors, and resistors all together is the most important unit of all, or the variable of all, and it also happens to be the last unit that we will, or the last variable we will study in AP Physics, is Z, and that is Z. We've arrived. The final variable, Z, is the impedance. All right, so Z gives you the overall, and Z is basically like the Pythagorean theorem. Z is also measured in ohms, omega. And so Z is equal to the square root of R squared, the resistor squared, plus X squared. There are different, resistances, but these resistances are from actual physical properties of, changing, fluctuating the voltage over and over, with magnetism involved, etc. Whereas the resistance from a resistor was purely based on mechanical properties, as the charge is trying to flow through a dense material, or electrically conductive material, I should say, not dense. Yes, headphones use inductors, so yes, therefore you have impedance measurements. All right, so Z is your impedance, your overall resistance. If you have more, circuit elements involved in your circuit besides just resistors, and so by putting it all together, when you solve the differential, you get current as a function of time, or if you solve for Q dot, current or Q dot as a function of time is equal to your max voltage divided by Z, the impedance, capital Z, cosine omega t. And we'll go ahead and add a phase angle to this. So your current could be lagging or leading behind. Same phase angle as before, where the phase angle is equal to the arctangent of, we have police. Not here, on the street somewhere. Or it could be an ambulance, who knows. X, the reactance, capital X, over the resistor. All right. So, LRC circuit, you should know what reactance is. You should know what impedance is. And this formula, you don't have to derive it because we don't technically need differential calculus for this class. Anything involving differential calculus is just part of the derivation. It's not actually part of calculations that you would have to do. All right, so z is your last variable. Tomorrow we will talk about Hall effect, how to actually use this stuff to sense magnetism, and then that'll be it. And then we'll review a little bit Wednesday you're taking your test, and then starting Thursday we'll review mechanics. Thanks for tuning in. Make sure you turn in your homework. It's due at midnight. I'll see you next time.